But anyway, let's get back to the project at hand. Yeah, that's pretty good. I'm sitting down because I'm gonna do some welding sitting down today. Bring you in a little closer. Apologize for my videography skills. I have several friends that are professional at this, and they would probably cringe at my skills or lack thereof. I'm all electric where I'm at. I have a heat pump and it works really well. Only problem is when it gets below 25 degrees in the winter, which it does, that's throughout the winter months here in Arkansas. My heat pump, you might as well turn it off because it can't cool outside air when the air is below 25 degrees. Which is pretty nice because a lot of the lower efficiency models of a decade ago couldn't go that low. But I have to supplement. I've supplemented with propane. That works pretty good. I've supplemented with electrical strips. Man, that's a dead short. That really runs up your power bill. So my solution to this is to build this project I'm building is I'll maybe have $500 in it total when I'm done. I've got about $400 in steel in it. So let me put you in here and let's show you what I'm doing here. I'll put these plans out on I'll put a link out on YouTube or what have you. But basically, yeah, that's not. I'm going to undock this. It's not just the greatest here. What I've built is a incinerator, boiler, whatever you want to call it. It basically will burn anything that is burnable. That's a 28-inch by 24-inch, I believe, mouth on it. I don't have the grill in it yet. And then I've got a little ash clean out. Actually, I can hook up to my, right down here, I can hook up to my wet dry vac. Once the ashes are cold, of course. Sweep all the ashes to the front and actually suck them out. And they're already contained. I just bag them or turn them into to fertilizer. Potash is really good and is really high in potassium. Potassium or phosphorus. My ag teacher would get me if I didn't remember that. Anyway, so this is just basically a stove, an outside stove. I went with this kind of design after working along with it on CAD. I'll show you in the plans. This is mainly to minimize on the steel I need and maximize on the efficiency. The heat exchanger, excuse the angle of bends here, is just a bunch of 1.25 inch, I think it's 1.25 inch, 1.5 inch Schedule 40 pipe. Now that is, this has been tested. That looks horrible because I actually tested it last year in a test apparatus. So basically I just pump ethylene glycol and antifreeze through this, and I can run this up to 260 degrees without fear of boiling. And this is just a heating loop. It circulates through this in the fire pit here in the box, excuse me, stove. And then it circulates back into the house. I've got a little 12 volt DC pump that I can run off of batteries, so even if the power goes out, I can still heat the house. Here's the little tray right here where that actually slides in. If I can get a better shot of that. So it just slides in, and then all the fire's right below this, and the heat, let's see if I can zoom you out a little bit. The heat basically comes up and goes around it and through it, and then of course the exhaust is right here, right above them. And then I've got a plate that I can bolt on here or take off, and if I need to service it, which I'll probably maintain it once or twice a year or once every couple of years, just to make sure I don't have creosote built up and everything. Anyway, the exhaust pipe is right there. Well, there's where it will be. It's got it's an 18-inch exhaust pipe with a damper on it, and this damper will be servo controlled. I've got a little, I'll fly over here a little bit. Right down here, if you've got an old Weber grill or know what I'm talking about, you'll recognize this little guy. This is just my own little damper. I think it's, yeah, there it goes. That I can turn it to get combustion air. And again, it'll be servo controlled. So the idea is I can smolder, usually wood, paper, trash, whatever I can burn, whatever will produce heat. I want it to basically smolder between 200 and 250 degrees. And hopefully I'll keep that heat exchanger at about 200 to 220 degrees while it's circulating through the house. I'm an Arduino fan, so I'm kind of a mechanical, electrical wizard. That's what my friends call me. I call myself an amateur because that's really what I am. I'll bring you in for some of the other stuff where I'm actually doing the circuitry and putting the servos on. So the Arduino is going to monitor the exhaust temperature, the water inlet and outlet temperatures, and I think the outside temperature, just because I can. And then it's going to let's see, well, and then of course once it comes into the house, I can monitor the air temperature after the heat exchanger. Well, I'm using it basically. It's an old A coil that I converted from. Just took the copper, I just left it in the A-frame coil, and I cut the fittings off and basically resoldered it so that it's just I can pump antifreeze through those 3/8 inch lines instead of Freon. Came out of an old air conditioner that I replaced in a previous house. So that's what I've got going on, and I think I'll just let the camera roll while I do some welding. I'm pretty sure it won't pick up the welds very well. Basically everything on this, every joint on here has to be welded. I don't want it watertight, but I want it close to, and it really doesn't have to be airtight, but I want it to be tight enough that when I close the dampers that I can shut it down. That's the primary. I'm going to program the Arduino such that it'll have, with all of its sensors, if it reads anything above, it'll shut down it'll turn both the exhaust and the intake damper down, and then if it's still the temperature continues to rise, then of course it sets off an audible alarm, and I may come back and put another safety on it so that it will basically dump water or antifreeze on the fire to put the fire out. This unit, you don't see it on the heat exchanger, but this unit will have a 10 pounds per square inch pop-off valve. So if the antifreeze does go to boiling, it will blow off outside and not come into the house. I guess I'll just let you sit here and watch some welding and grinding. You can tell a good welder by the amount or the lack of grinding that he does. If you can see around on the floor here, I've been grinding quite a bit. There's iron steel filings everywhere. Some of that is from when I cut all the pieces out with an arc welder, or not an arc welder, excuse me, a plasma cutter. But a lot of it is from me grinding my welds down, looking for holes, and then re-welding it. So that's probably what I'm going to be doing. You can hear the welder buzzing in the background. You'll probably hear a little bit of the radio, but mainly you're going to hear me welding and grinding. And I will probably edit some of this out, but I'll give you a little bit of it just to show what goes into building what is essentially a big steel box. The materials I'm using it's 7 gauge steel. That's about it's 3/16 of an inch. It's heavy. It's a 4x8 sheets. These are about 250 pounds per sheet. And I've got 2 sheets in this box you see here, plus all the extra welds. Anyway, that's all I'm going to do right now. I'm just going to go ahead and I will warn you, most of my grinders do not have the shields on them. I do not recommend running a grinder without a shield on it. Mainly because with the shield you can kind of direct and somewhat control where the sparks are going to fly and make sure they're not flying towards your face. One of my grinders I bought used, it didn't come with a guard. The other one I lost the guard off of it. So follow the manufacturer's recommendations unless you're extremely good at it. If you are, then you take it, your own livelihood in your own hands, and that's fine. I do that. But the guards are on there for a reason, and they do keep you safe. So with that, I think I'm going to move the camera a little bit, and we're going to set up and actually weld that top angle piece where it goes to level off onto the very top of the up there. And so now at the end of the day, I don't know if I'm even in the shot here. Anyway, at the end of the day, I usually paint all of my welds to make sure that they don't, if we get a rainstorm or whatever and the humidity jumps up, and shit, so Arkansas, it tends to jump up pretty high most of the time. I don't want any rust, so now I do now have to go back and sand off all the paint, which may bring in more contaminants than the rust. But anyway, and I would definitely, like what I'm doing here where you're grinding and welding, I typically wear earplugs. Definitely protect your ears and your eyes. If you're going to do a lot of grinding, even if you've got glasses on, that doesn't necessarily mean that those sparks can't get around your glasses, because I've had a few very close calls where I almost got metal in my eye, and I've known some gentlemen that had that happen, and it's excruciatingly painful. So you'll see me put on a full face mask, where I'll pull my visor down where I'm just barely looking underneath it to prevent some of the sparks flying in my direction. My main grinder that I do the surface grinding with does have a guard, and I can kind of point the sparks in a direction. So anyway, let's actually do some work. I have to plug this in first. Prep. What I do when I'm welding, let me get my welding tool right here. I'm a self-taught welder. I have a lot of good friends that are professional welders, and any advice I'd give to the next generation is you do not necessarily have to go to college. If you learn how to weld, plumb, you learn a trade, you can make just as much money as most college grads by learning a trade. So we need all trades. This country is not built on just college graduates. So that's really all I'm going to say about that. If you know a welder or a pipe fitter or electrician that's been at it a long time, or at least a few years, 5-10 years, trust me, they know their job, and there's no point looking down at them. I don't care if they didn't, what school they completed, they are professionals. And anybody that's a good welder, which I am not, will probably cringe at this, and I apologize, I'm still learning. I've learned a lot on this project, and hopefully I can give you some tips. Maybe lesser welders can come up and get a little faster, learn faster than I did. The technique you'll see me using is I basically draw little overlapping circles. I've tried zigzags, I've tried just pushing a bead, pulling a bead. I've tried figure eights, and sometimes I'll do a figure eight if I'm needing to cover a wider area and lay down a heavier bead. But just small circles that overlap seems to get the pool. It allows me to lead the pool of molten metal over the joint, and keeps it going pretty good. I use a little Lincoln Electric. It's over there. I'll show you later probably. Just a wire feed. This is flux core. I've got some MIG and some MIG wire. I just have not played with it. I've taught myself how to weld with the flux core. So anyway, let's get back to doing some work here. Find my earplug. Since this is a pretty large work piece, I'm gonna run about 4 to 6 inch weld, and then I'm gonna skip over. So I'm gonna let basically the heat from this weld is gonna kind of move out into the colder areas of the steel, and I want to kind of let it be somewhat uniform so that the shrinkage doesn't kill me. I haven't had much trouble with shrinkage because this is a big piece and I've tack welded everything before I actually went back to doing all the seam welding. But I still want to kind of hedge my bets so I don't have any shrinkage and extra stress and that kind of stuff. So just makes a good habit. And if I'm wrong, please comment below. For all these tips, I'm just kind of bringing you along this journey just to let you see, hey, what you can do, give you some ideas. I'm not a professional, and if anybody wants to comment, please, I'll feel free to criticize me however you want. You know, be somewhat kind. But yeah, I'm always trying to learn. I don't think we ever stop learning until we're 6 feet under. So, if you got some words that you want to throw at me to help me with my hobby, please feel free. So anyway, I'm going to make one. One thing that I will tell you, I can't weld more than about 3 feet. That's a 36 inch long piece. I can't weld more than about 36 inches at a time because my little Lincoln arc is, I think it's only got about a 70% duty cycle. So if I don't give it some time to cool down between welds, then it'll eventually force me, it'll kick into neutral and the fan will run, but it won't let me strike an arc. So anyway, you'll see me start and stop, and that's, I'll weld a while, then I'll grind a while, and inspect. That's twofold. That's one, to let the welder cool itself back down, but also for me to inspect for cavities and any nicks where I think that the weld might be weak. This is going to be a firebox, so it's going to be heating up and it's, expanding and contracting and stuff. So I want this to be solid. I don't mind that it heats up, and I just don't want any of the welds cracking in the middle of it. So I will have a burn-in period with it. I'll test it. I'll get it pretty hot. I got to get it pretty hot to burn all this primer off, and then I'm going to come back with some 2,000 degree, basically cylinder or engine head or block paint, ceramic, get some ceramic base, so that it'll stay, somewhat rust-free. I'm sure I'll have to paint it every year, but that's to be expected. So I'm going to show you what I did here, and it's not the greatest. Some of these are okay, some of these are okay, some of them, oh my gosh. And yeah, I did it. I'll own it. It may not be all that pretty, but that's the kind of welding I do. And now granted, that's a lot better than when I first started on this project. So, but I'm going to go back and grind that off now, and we'll see if we've got, and I'm grinding it for two reasons. One, I want to see what kind of weld I've got underneath there to make sure it's solid, but I also want to make this, eventually I want to make that smooth. I don't want to grind all the weld off of it, but I want to make it fairly smooth instead of having a big bump there, just for aesthetics. But I'm not going to grind all the weld back off, because it's actually, I couldn't grind all the weld off without making a big mess. But because it's done, and I'm running at 75% heat. I'm not sure what that is in this welder. It's at least, I don't know, I'd guess it to be 100 to 115 amps. I don't know what the max is, but I'm running pretty hot, and so I'm melting this, melting down in there quite a bit. And then with the swirling, I'm hoping to build up a little pool so that when I do grind it off, I've got enough weld down in the, where I actually melted two pieces of metal together that I can grind it off and not lose a whole lot of strength. And makes it look a lot better. So anyway, I'm going to put my grinding helmet on and we'll get to work. Now personally, I run Milwaukee and DeWalt. I have a little Task Force cheapie that I got from Clarence at Lowe's. Works great for sanding, but my heavy duty stuff I'll usually do with Milwaukee or DeWalt. Both of these I've been running for 15 years, kind of amateur commercial. Haven't had a lick of trouble out of either one of them. This is not an extensive tool review, this is just one man's opinion, but I like both of these models. This is my basic post-weld grinding. I'm just bringing it down to where it's rounded over. You can see in here I've got some inclusions where I had, you know, air bubbles or gas bubbles or slag in there, and it didn't allow a good weld. I mean, this would hold, but I'm trying to do a better job than that. I'm trying to get to where I can, you know, have less and less of those. So I got a few down there, so I'm going to go back and spot weld those and then regrind so that those are gone, and then I'll come back with a sanding disc. I'll show you that in a little bit. Okay, that's a lot better. Show you a quick shot of that. Just a basic grinding with my my surface grinder. Let's see, I'll just hold this up here. I run 3 different grinders. Over the past 10-15 years, I've been able to collect several. I bought 2 good ones, then I got, like I said, I got that clearance one, that little Task Force Lowe's model on sale with no guard and no handle, but it's great for what I use it for. I think these earplugs out, it's hard to talk that way. I use a flat disc on it, and the flat disc is what I do for paint prep, metal prep, post welding to get all this. I don't know what that is. It's just like a film, but it's part of the flux, I'm sure, that the flux gas that condenses on the steel. And also to get all the little splatter marks, the little pebbles that come off and stick to the steel. I go in and clean all those off with that flap disc. It doesn't do like this guy does, and you know, does a lot of aggressive chewing of the steel. It just basically just makes it pretty, like I say, makes it pretty, and kind of does some fine dress work. The other, my DeWalt, I've got it set up on a grinder. I'm running some thin discs on it, and I just use it for cutting steel if I'm cutting off bolts or cutting something this size. That's what I've got it set up for. So I have 3 set up differently. A lot of machine shops, a lot of guys that I follow on YouTube, they'll have like a dozen different grinders, and each one of them they probably have 2 of each set up for cutting, grinding, and they may have different types of grinding. We have and different types of sanding discs on there. So if you can afford more than one, it's nice to have at least 2, one for cutting and one for grinding, because you can do it all with a grind. You can do all your grinding with a cutting wheel, but it's not going to last very long. It's not nearly as heavy duty as a 1/4-inch grinding wheel. As you can see, this one's pretty well done. I mean, I'm going through these pretty quick because, again, I'm not the best welder in the world. So but you go through them a lot faster if you're using these little thin cutting wheels. I'm actually running 2 on this one, if you can see. I'm actually running 2. These are cheap. These are Harbor Freights. They're okay, but they're kind of flimsy. And the little supports, the little support rings that they stamp in them when they make them are cheap. So if you don't run 2 of them, they break really easily. But that's another thing. If you want to have less headache, buy a little better tools, a little better consumables even. You know, I thought, well, grab, 10 for like $5, that's great. Yeah, not really, because you go through them twice as fast or 3 times as fast. You kind of get what you pay for. So I'm going to do a little cleanup here, and then I'm probably going to turn you off because you may have heard a while ago that was my wife coming in telling me that she's here. I try to balance my work time, shop time, and family time. I've got a little daughter, and I've got another one on the way. We're not sure if it's a boy or a girl, but either way, I like to see them for a couple hours before they have to go to bed. So this is basically an introduction to me, and I'll tell you some more about my goals for this channel and stuff as I go along. I do want to show you real quickly the little Lincoln Art, this ST100T. I bought this thing as a refurb in, I think it was May of '03, and I've run the dog snot out of it. And I've never had any trouble with it. This is a great little welder. I don't know what the current model number is. This will do MIG as well as FluxCore. You just have to flip the polarity on the leads. But it's a great little welder. I think I paid like $330 for it. And like I say, it's been running for 12 years with no problems. And I think that $330 includes the little stand and everything. And back there in the back, if I turn this a little bit, I do have a MIG bottle. And it comes with a regulator and all this kind of stuff. And I've played with it, but I've never understood what I was doing. Didn't have the pressure right, didn't have the wire right. So, got to go back and work on that a little bit. I've got a buddy that's all he does is MIGs. He's kind of got basically the same setup, but he MIGs all the time. He says it's so much better than FluxCore. So, I'm going to get some advice from him and kind of teach myself how to MIG. So that's kind of what I want to do with this channel. I want this kind of to be a mentoree channel. Anybody out there that wants to watch some idiot waste his time, possibly grinding and cutting and welding and all this kind of stuff. Maybe you could pick up a few hints, make some less mistakes than I make. That'd be awesome. But also, I'm sure there's plenty of pros that like to watch, possibly like to watch idiots like myself make mistakes. Hey, I'm human. So, if you have any criticisms, feel free to write me, post comments on here, because I want to learn too. This is not my job. I'm a computer nerd during the daytime, and I do this in the evenings, and I'm just kind of messing around. I have a lot of hobbies, and this project is going to try to combine a lot of those hobbies into one. So anyway, as far as that goes for this evening, I guess I'll leave it rolling while I clean up this weld a little bit more. But this is a Chevy Fan 58, and I'll see y'all later.